Hi Ellie. Last time we saw how to use these two triangles, the 30, 60, 90. And I don't think I showed you the 45, 45, 90, but you use it the same way we did the 30, 60, 90. For example, sine 45 degrees is opposite over hypotenuse. That's 1 over the square root of 2, which is often rationalized to root 2 over 2. Okay, we also looked at this little chart which told us, which helped us find trig values of general angles. So as a review, let's do a problem practicing that. Okay, so let's say, for example, as our first example, what I want you to do is I want you to find the trig values of 240 degrees. Okay, so what we do is we take 240 degrees and place it in standard position. Alright, so that's the start rate, goes along the x-axis. Alright, so we're going to go 180 degrees all the way down to, let's see, all the way down to 30 degrees short of 270 degrees. Alright, so that's 180 degrees and another 60 degrees to get us to, here's 240 degrees. Alright, now look at this angle. Now we have to find the reference angle. Alright, this is the x-axis. Now remember, the reference angle is made by the terminal ray and the x-axis, so that would be this angle over here, not this one, okay, because that's made with the y-axis. It's right here. So there's the reference angle. Okay, so here's the reference angle, and what is it? It's 240 degrees minus 180 degrees, so that's 60 degrees. That's our reference angle. And from our little chart here, we see that only tangent is positive in this quadrant. All right, so sine 240 is equal to tangent 60. Tangent 60 we get from our triangle. Tangent opposite over adjacent, so that's square root 3 over 2. No, sorry. Now opposite over adjacent, that's square root 3 over 1. So tangent 60, that's square root 3. Alright, cosine 240. Sorry, and yeah, so that's positive. That's positive because tangent's positive in this quadrant. Alright, so now we're doing cosine 240. That's minus cosine 60. That's minus a half. We got that from our triangle also. And sine 240. That's minus sine 60. Okay, that's, just pull this up a little bit. Okay, that's negative square root 3 over 2. Alright, so that's just a review of what we did yesterday. Let's go on. Let's look at this. Let's look at this sheet a little bit more. Alright, let me, just a minute here. Let me just make this white. Okay. Alright, let's go on. Let's look at this sheet. What else do we have here? Okay, we have some more trig functions. We have secant, cosecant, and cotangent. Secant, like you say, like it says here, is 1 over cosine, and cosecant is 1 over sine, and cotangent is 1 over tangent. All right. So, for example, if we wanted the secant of 30 degrees, well, the cosine of 30 degrees is square root square root 3 over 2. So the secant is the reciprocal of that. That would be 2 divided by the square root of 3. All right, let's look at this circle here. Let's understand the circle. You asked me about the circle on the phone. All right, so let's look at that. This is a circle. The circle I drew here is a circle with radius 1. Okay, so this is a circle with radius 1. And I drew it on a set of xy axes. Alright, so this point over here is 1, 0. Alright, the equation of the circle is x squared plus y squared is equal to 1. Alright, now if we look at an angle theta, we put it in standard position on the circle. Alright, this is a radius. The terminal side is a radius of the circle, so it has length 1. Here's my angle theta. Alright, now let me just draw a perpendicular coming down here. Okay, so we know that, for example, cosine theta is adjacent over hypotenuse, that is in this triangle here, in this little right triangle. Here's the adjacent and here's the hypotenuse. Well, the hypotenuse is 1. Okay, so cosine theta is this length, the length of this horizontal side of the triangle, divided by 1. So this length is actually equal to cosine theta. Alright, so right here, this length, the length of the bottom of that right triangle, that's cosine theta. And sine theta is the vertical, the opposite, over the hypotenuse. Again, since the hypotenuse is 1, this side is must actually be equal to, the length of that side is actually equal to sine theta. Okay, again, this length over 1 is sine theta, so that is sine theta. Okay, so that means that this point here on the circle has coordinates. Let's see, to get to this point we go over cosine theta and we go up sine theta. Alright, so the coordinates of that point, let me just make some room here. I'm going to erase this just to make some room. So the coordinates of the point over cosine up sine are cosine theta sine theta, cosine theta sine theta. Alright, so that's what I showed you over here. You see cosine theta sine theta? So if we have a circle of radius 1 with equation x squared plus y squared equal to 1, each point on the circle has coordinates cosine theta sine theta, where theta is the angle underneath the radius. All right. So let's do a specific example. Before we were looking at angle 240 degrees. Okay, here's my circle. We were looking at angle 240 degrees here, say. Alright, so this is cosine 240. And this is sine 240. That's this point, the coordinates of this point. Alright. So whatever we found for cosine 240, that's this coordinate, and I don't remember what we found for sine 240. Well, that was based on, let's see, the reference angle here is 60 degrees, and over here only tangent is positive, so this would be a minus 1/2 here. It's negative cosine 60, and this would be negative sine 60, which is minus root 3 over 2. So those are the coordinates of this point, angle 240. Okay, let me mention